My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 627. In this lecture, I will continue my discussion on transfer learning. Let's say there are multiple cases. So let's take case 1 here. Let's check VGG 16 for sample. If you look at the architecture, this is one way of looking VGG 16 architecture. You have the first convolution block, you have second convolution block, third convolution block, fourth convolution block, fifth convolution block. You have bunch of convolution blocks. What you have just before the flattening layer, just see here you have fully connected classifier. What you have just before the flattening layer, look at this end of this max pooling 2D. Look at this one, end of this particular one. Here I have max pooling 2D. At the end of this max pooling 2D, what you have here just before the flatten layer, what you have here just before the flatten, as soon as you flatten, what do you get? You will get basically, as soon as you flatten, you will get basically an array of features. You get basically a linear array at the time of flattening. These features are called bottleneck features. Just see, these features are known as bottleneck features, isn't it? That's what it says. So what you can do for your task is this. First way is you can use pre-trained model, isn't it? You can use pre-trained model. Let's assume I'm using ImageNet. What I can do is ImageNet. If I just imagine I have a data set. I have a data set capital D. D is xi's and yi's. D equal to xi and yi. Let's assume these are images of cats. I can say these are images of cats and dogs. My yi is basically cat or dog. It is a two class, I can say it is a two class classifier, isn't it? It's a cat or two classes means cat or dog. Xi, what is xi? These are actual images. So what I can do here is I can take my VGG network. I can just let me take VGG network. I can input each of my x's, my dog and cat images. That's, isn't it? And instead of running the whole network, this is important, instead of running the whole network, we can run the network only till the flatten layer. So what am I doing here is I can take my VGG network. This is my VGG network. I can input each of my dog and cat images, and instead of running the whole network, I can run the network only till the flatten layer. So what am I doing here is instead of learning the whole network, I will remove the last dense connected layers. I will remove which layers? I will remove last dense connected layers, isn't it? What does it mean? Just see, that's what it says. I will remove the last dense connected layers. What I get here, just see, this I'm removing this last dense connected layers. What I get here, just at flatten layer, what I get is a big vector. Just see, at flatten layer I will get a big vector. What will do here is I will reuse VGG, isn't it? I will reuse VGG, but I will skip last dense connected areas. remove dense, isn't it? These are you can see here, if you observe carefully, these are convolution layers. These are convolutional layers, isn't it? Convolution blocks. You can see here convolution block 1, convolution block 2, convolution block 3, convolution block 4, convolution block 5, something. These are dense vectors. These vectors are known as dense. Remove dense vectors. That is important, isn't it? These are convolution blocks, isn't it? These are convolution blocks. All these are convolution layers. You have lots of convolutional layers. So I will take the output, isn't it? I will input xi. Which one is input? This xi is input, isn't it? This xi is input. What will I get here? If I give xi, I take this vector. I will take this vector. I will input this vector xi. Input vector xi to VGG16, isn't it? Just see. Let's take this vector. Now, if I input xi vector, let's go. What will I get? I will get here some vector where, just let me show otherwise. This is my input vector. This is my, let me show like this. This is my input vector. Here I will get some vector before removing this dense vectors, isn't it? Here I will get some vector where, just observe, here I will get some vector, isn't it? That vector I am calling as xi dash. Please try to understand difference between xi and xi dash. Xi is input vector, my VGG16 VGG network. Here I will get some vector. That vector I am writing as xi dash, isn't it? My xi is the image from my original data set. That's important. Xi is the image from my original data set. My xi dash is a vector. My xi dash is a vector that I got by using the bottleneck features. So these features are called bottleneck features just before the flatten. Just see, here we have seen bottleneck features just before the flatten layer, isn't it? So I will actually flatten them. What do I get here? I get a d-dimensional vector. So for every image, this is important. For every image, my x1, x2, so on, xn, in my data set capital D, I will compute corresponding x1 dash, x2 dash, so on, xn dash using VGG network, isn't it? See here, I am using VGG network except for the last few layers. That's what it says. X1, X2, so on, xn. I have input images are x1, x2, x3, so on, xn. I am calculating x1 dash, x2 dash, so on, xn dash, isn't it? Because look at what is happening in if you observe this x1 dash, x2 dash, just if you observe carefully what's happening here, just anyway I will repeat it once. I have input images x1, x2, so on, xn. By using VGG, I am creating x1 dash, x2 dash, x3 dash, so on, xn dash. Of course, I am not using these dense layers for creating. I am not using dense layers. These layers, I can say this one. I am not using these dense layers for creating x1 dash, x2 dash, so on, xn dash. The first convolutions, actually what's happening here, just see, the first convolutions are actually detecting edges. This convolution block 1, it detects edges. By the time I come here, I have bunch of edges. That's important, isn't it? By the time I have in convolutional layer, I have bunch of, it detects bunch of edges. In convolution layer 2, it detects group of edges. By the time I come here, I have group of edges. So probably by the time I come here, just if you by the time I come by the time I come here, flatten layer, bottleneck features here contains this may contains a vector representation of image, which could say, does this image contain something like circle, does this image contains circle like this, does this image contain triangle like this, does this image contain a cat or cat type faces, or does it contain a tail, tail faces, does this have four legs, four legs, so on and so forth, isn't it? Representing like this, isn't it? While this whole network is training for object, this whole network is trained for object recognition. VGG16 is trained for object recognition. Remember, ImageNet itself, ImageNet has tons of images, isn't it? ImageNet has tons of images of cats and dogs. So what you are doing here is you are reusing VGG, we are reusing VGG-net, as I can say we are reusing VGG net, but instead of using the whole network, they are using all the convolutional layers. So you are using VGG net as a feature engineering tool, and the vectors that you get here is called, isn't it? We are using VGG net, but instead of using the whole network, we are using all the convolution layers. We are using VGG net as a feature engineering tool, isn't it? Just see, the vector you get here is called CNN code, isn't it? That xi dash, isn't it? The vector, which vector? Here we are getting xi dash. This is xi, this is xi. You are getting xi dash, isn't it? This xi dash, these vectors are known as, these are called as CNN code, because what it is doing, you are using convolutional layers of VGG network to actually convert an image into a vector, into a code, and now I have my x1 dash, now I have my x1 dash, x2 dash, x3 dash. I have this new data set. Let's call this data set as d dash. Let me say this data set as d dash equal to x1 dash, x2 dash, x3 dash. Correspondingly I have y1, y2, isn't it? Now I have this new data set. Correspondingly I have y1, y2, y3, so on. Isn't it? I will train a simple model because I have two class classifier. I can train a simple linear model like logistic regression, isn't it? I can train a simple model like it's a logistic regression, a simple model. Why? Because you have x1 dash, x2 dash, so on, xn dash. Corresponding you'll have y1, y2, so on, yn, so that you can make use I have to as I have two classes, I can train model like logistic regression. This is case 1. In case 1, what are we doing? In case 1, what are we doing? We are using bottleneck features just before the, you are using bottleneck features just before the flatten layer or at the flatten layer. We are using pre-trained model. That is important. Here what we are doing here, we are using pre-trained model. We are using pre-trained model of VGG 16 plus ImageNet. VGG 16 plus ImageNet as a feature engineering tool to create as a feature engineering tool to create, which one you are creating? You are creating CNN code, that is xi dash. Xi dash means you are creating x1 dash, x2 dash, so on. We are creating X and dash, isn't it, to create a CNN code. So we are using this model, we are using the model that exists. The model has been trained on ImageNet. We are reusing it. As a feature engineering tool. Okay, this is case 1. In my next lecture, I will discuss about case 2. Thank you very much.